All right, so today we're looking at linear systems, again, systems of equations, but this time instead of just having two variables, we're going to have three variables. When we have a system with three variables, we are essentially down to two different ways that we can solve elimination and substitution. But in all reality, solving a system of three variables kind of combines your elimination and substitution methods. So we're going to do these the easiest way we can so that you can kind of see what to look for, things like that. We're going to start off with an easiest, best case scenario and then move on to examples that are a little bit more involved. So when we look at number 1, we have x minus 2y plus 4z equals 4, y equals 3, and y plus z equals 2. So anytime that you have a variable that already gives you what it's equal to, so like in this case, y equals 3, we're just going to use back substitution as much as we can. So we got y equals 3 for that middle equation, and then that bottom equation, we have y plus z equals 2. Well, we're going to plug that y equals 3 in for y in the third equation. So 3 plus z equals 2. We're going to solve for z. And then, now that we have y and z, we're going to plug that into our first equation so that we can solve for x. So negative 2 times 3 is going to be minus 6. 4 times negative 1 is minus 4. I'm going to combine my like terms to get x minus 10 equals 4. And then I'm going to add my 10 to get 14 for x. Now, when we were just solving for two variables, we would write our answer as an ordered pair. The only thing that changes here is we now have 3. So instead of writing our answer as an ordered pair, we write them as an ordered triple. So an ordered triple is just x, y, and z. So our x value was 14, y was 3, z was negative 1. So that is our final ordered triple. I encourage you guys to do number 2 on your own. We're doing the same thing we did in number 1. We already know one of our variables, so we're just going to back substitute. So pause the video, work number 2 out, and then come back and compare what you got for yours compared to what I got for mine. So we already know that z equals negative 5. So I'm going to plug that in for z in my second equation so that I can solve for y. Which gives me negative 1 for y. And then I'm going to plug that negative 1 in for y in the first equation, negative 5 in for z, so that I can solve for x. So I end up with 22 for x, and then we're just writing our ordered triple for our final answer of 22, negative 1, negative 5. With, 3 and 4, we're going to look to do similar things as much as we can, but it's going to come a time where it might give us the answer to one variable, but it doesn't help us find the other two, which in that case, we would have to use elimination or substitution. So in number 3, x plus z equals 4, y equals 2, 4x plus z equals 7. So we know y equals 2. We don't have to do anything else to solve for y. So we're going to look at the first and third equations so that we can solve for x and z. I'm going to use elimination. And then what I notice is that if I were to eliminate z, I've got a positive z and a positive z. So I'm going to multiply this first equation by -1. Because now I can just add these two equations together and solve for x. So 4x plus -x is 3x. Z plus -z is 0. 7 plus -4 is 3. I divide by 3 and get 1 for x. So now I know x, I know y, and now I just have to substitute in for either my first or third equation to solve for z. So I'm going to plug into my first equation. So 1 plus z equals 4, which is going to give me 3 for z. So I write my ordered triple of 1, 2, 3, and that's my final answer. Okay, so in number 4, we're looking at one that does not automatically give us the value of one of our variables. We have x plus y plus z equals 6, 2x minus y plus z equals 3, and 3x minus z equals 0. Now, that third equation doesn't have a y variable. And the first two equations, the y value is +1 and -1. So if we were to add those together, we would eliminate that y value. So that's exactly what I'm going to do. So I've got 3x plus 2z equals 9. Now I'm going to take this new equation that I got and this third equation that I haven't used yet, and I'm going to eliminate another variable. Now, we have a couple options. I've got a 3x and a 3x, so I could change the sign of one of those and add them together. I've got a -z and a 2z, so I could multiply this third equation by 2 and add and eliminate there. I'm going to go ahead and choose to multiply this third equation by -1 so that my x's will cancel out. It's just a little bit less work. So I'm adding it to this equation here. And then I'm going to eliminate my x's so that I can solve for z. So I end up getting 3 for z. And now I can start back substituting. So if I plug z into either my third equation or this equation here that I got when I added the first two equations together, that's going to solve for x for me. So I'll just go ahead and plug it into that third equation. So I've got x equals 1 and z equals 3. And then I'm going to plug it into one of my first two equations so that I can solve for y. So now I'm going to go with the first equation since y is positive. So I plug in 1 for x, 3 for z, so that I can solve for y. I subtract my 4 to get 2, and then I write my ordered triple of 1, 2, 3. I promise the answers are not always 1, 2, 3. It's just a coincidence that 3 and 4 had the same answers and that it was 1, 2, 3. They could be any numbers, positive or negative. Okay, 5. We are at 3 equations and 3 variables in all of the equations. So first thing you have to do is decide what variable do you want to eliminate first. My suggestion, since we have a 1x I would eliminate my x's first. Now really pay attention to what I'm doing here. If you're not sure what I did, go back and watch again. If you're still not sure what I did when you're watching this in class, connect to me on the Zoom chat or send me an email so that I can help walk you through it a little bit more. But basically, we're going to use one of our equations twice. In this case, we're going to use this first equation twice because it's the 1x. So first thing I'm going to do is I'm going to multiply this first equation by -3. And remember, when we do that, we have to multiply every single piece by that value. And then I'm going to add that to my second equation. So my x's add to 0, -20y minus 3z equals -28. And now I'm going to multiply that first equation by -5 because I want to be able to eliminate the x's with the first equation and the third equation. So -5x minus 30y minus 10z equals -45. And I'm going to add that to my third equation. So when I add those together, my x's add to 0, -35y minus 8z equals -38. So now I've got to look at these new equations that I got after I added together, and I'm going to eliminate again. So it doesn't matter which variable you choose to eliminate. I'm going to have smaller numbers if I eliminate my z's. So I'll change the colors so that you can kind of follow a little bit better. I'm going to multiply this top equation by 8. And this bottom one, I'm going to multiply by -3. The reason I'm multiplying by -3 is because we've got a negative and a negative. One of those has to become a positive. So that's going to give me -160y minus 24z equals -224. And in the other one, when I multiply by 3, 105y plus 24z equals 114. So I'm going to add those together. So I've got -55y equals -110. I'm going to divide by 55, -55, and I'm going to get 2 for y. So now I'm going to take that 2 and I'm going to plug it into one of these two equations that we had when we added together. It doesn't matter which one. I'm going to go ahead and plug it into I'll just say the first one up here. So -20 times 2 minus 3z equals -28. So I'm going to add my 40 to get -3z equals 12. And I'm going to divide by -3 to get 4 for z. And then I'm going to plug in my z value and my y value into one of the original ones to solve for x. I'm just going to use the first equation since it's a 1x. 6 times 2 is 12. 2 times negative 4 is negative 8. I want to combine my like terms, subtract my 4 to get 5 for x. So I've got my ordered triple 5, 2, negative 4. Ones like number 5 are as hard as they're going to get in terms of process. If you can make it through number 5, you should be fine. I would even suggest maybe watching number 5 specifically twice so that you really are following what I did for each step of the way. If you want to try number 6, pause it, see if you can work it out, and go from there. Okay, so number 6 hopefully will be a little bit easier for you since each of the equations only has 2 variables. So you just have to decide which variable you want to eliminate. So 6y plus 4z equals negative 12, 3y plus 3x equals 9, 2x minus 3z equals 10. I'm going to just go ahead and eliminate my x's in the second and third equations. So I'm going to multiply my first equation by negative 2, my third equation by 3. Remember, we just need a positive and a negative. So since they're both positive, when we multiply, we need to multiply by a negative for one of those. So that's going to give me negative 6x minus 6y equals negative 18. And 6x minus 9z equals 30. Now keep in mind, we have a y in the second equation and a z in the third equation. I would leave a break where your z would go in the first equation and the y would go in your second equation so that you don't accidentally add together the y and the z because they don't have the same variable, so we can't combine those. So our x's add to 0, negative 6y minus 9z is going to equal 12. So now we want to look at this first equation and then this equation that we just got when we added it together. So we've got a negative 6y and a positive 6y. So if we add those together, the y's are already going to add to 0. So we don't have to multiply by anything. So negative 6y plus 6y is 0. Negative 9z plus 4z is negative 5z. 12 plus negative 12 is 0. So that's going to give me z equals 0. I'm going to plug that into one of my equations. I'm just going to plug that into my, we'll plug it into my third equation. So 2x minus 3 times 0 equals 10. Well, 3 times 0 is 0. So 2x equals 10 is going to give me 5 for x. And then I'll plug into my first equation. I don't have an x, so I only have to plug in my z value, which was 0. 4 times 0 is 0. So 6y equals negative 12, which is going to give me negative 2 for y. So we're writing our ordered triple for our final answer. So hopefully number 6 was a little bit easier for you. When we move on to number 7, this is going to be another one where we have all 3 variables in each of the equations. It doesn't matter which variable you start with. My suggestion, since we have a 2x and a 2x here, would be to get rid of your x's eliminate your x's first. So I'm going to multiply my first equation by -1. And add it to my second equation. So my x's add to 0. 5y plus 5z equals 2. And then I'm going to multiply my first equation by a -3 so that I can add it to my third equation to get my x's to cancel. So -6x minus 3y minus 9z equals -3. My x's add to 0. 5y plus 9z equals 2. So nice thing now, when I look at these two equations, I have a 5y and a 5y. So I'm just going to multiply this first one by -1. And I'm going to add it to this second one. 5y's add to 0. -5y plus 9, or -5z plus 9z is 4z. -2 plus 2 is 0. I divide and get z equals 0. I'm going to plug that into one of these two equations up here. Doesn't matter which one. 5y plus 5 times 0 equals 2. 5 times 0 is 0. I divide by 5 to get 2/5. And then I'm just plugging into one of my other three original equations. I'm just going to plug into the first one. So 2x plus 2/5 for y plus 3 times 0 equals 1. 3 times 0 is 0. So 1 plus 2/5 is going to give me 7/5. And when I divide by 2, it's going to give me 7/10 for x. So my ordered triple, 7/10, 2/5, and 0. For the last one, number 8, x plus 2y plus 6z equals 5, -x plus y minus 2z equals 3, x plus 4y minus 2z equals 1. So x's are going to be the easiest thing because I've got a +1, -1, +1 for those coefficients. So I'm going to add the first two together. X's add to 0. 3y plus 4z equals 8. And then I'm going to add the second two together. Because it requires no multiplying, I can just add. X's add to 0. -3y minus 4z equals 4. Now I've got a -3y and a 3y. So I'm just going to now add those two together. Y's add to 0. My z's add to 0. 8 plus 4 equals 12. That's not a true statement. 0 does not equal 12. So this would be a no solution. Okay, your homework will be posted on Google Classroom. If you are not sure what to do, you have questions, get on the Zoom chat with me. Or if it's after our class time, shoot me an email, request a Google Meet, whatever you need to do to get a hold of me. If you email me, I'll email you back as fast as I can. Google Meet, I'll connect as fast as I can. But just take your time, walk through it. We are going to have a quiz the next class from 8.1 to 8.3. So it's solving all of our linear equations. I'm not going to care how you solve them. You're just going to have to pick your way to solve, and that's it. I'm not going to be looking for all of your work, so it's up to you how you solve it. It's going to have a blank for your answer, and it's going to be up to you to fill it in with the correct answer. Okay, so if you have questions, let me know. Quiz next class, and then we will start talking about matrices.